Module 4. Units: Assessing Science Learning. Assessing science learning in elementary students is a multifaceted process that involves both formative and summative assessments to evaluate and support student progress. Effective assessment practices are crucial for ensuring that students achieve the learning goals set out in the curriculum, and for providing teachers with the information needed to tailor instruction to meet students' needs. Formative assessment processes, when implemented as part of effective teaching practices, use feedback loops to help move student learning forward. These assessments are integrated into daily instruction and provide immediate feedback to both students and teachers. For example, embedding formative assessment tasks into a lesson or unit during planning allows teachers to identify the amount and type of scaffolding assistance needed by students. This approach ensures that students' progress toward understanding the learning goal can be determined before the end of the lesson, enabling timely feedback and adjustments to instruction. Formative assessments that are lesson embedded often rely on well-chosen questions. These questions help teachers gauge students' understanding and identify areas where additional support may be needed. For instance, asking students to write one thing they learned and one question they still have in their science journals each day allows the teacher to determine the effectiveness of the activities and understand what students have grasped. This process is an example of formative assessment, as it provides ongoing insights into student learning and guides instructional decisions. Another example of formative assessment is creating concept maps at the beginning of a unit. When students working in small groups are asked to create a concept map showing what they already know about a topic, such as electricity, it serves as a diagnostic assessment. This activity helps the teacher identify students' prior knowledge and misconceptions, providing a baseline for instruction. Similarly, using rubrics to evaluate students' sketches of mealworms' life cycles after months of observation is an example of summative assessment. This type of assessment measures student learning at the end of an instructional period and provides objective criteria for grading. Summative assessments provide evidence of student knowledge and understanding at the conclusion of a learning cycle. These assessments can take various forms, including tests, projects, and performance assessments. Performance assessments are particularly valuable as they can measure student understanding of several learning targets and require students to apply their knowledge in real-world contexts. Large-scale assessments, such as state and national tests, also play a role in evaluating the effectiveness of science programs at schools and informing changes needed at the school and district levels. Constructed response items, such as essays or short answer questions, require students to develop their own answers, demonstrating deeper understanding and the ability to articulate their thoughts. They can be part of a paper and pencil test and make up essay tests. Fill-in-the-blank items are constructed response items unless a word bank is provided. To ensure that assessments are effective, it is important to use a variety of assessment methods that provide a comprehensive picture of student learning. For instance, using diagrams and drawings as part of formative assessments can help students express their understanding in different ways and provide teachers with valuable insights into their thinking. Concept maps are another useful tool, as they allow students to organize and represent their knowledge visually, making it easier for teachers to identify gaps in understanding. The formative assessment scaffolding feedback loop is a key component of effective assessment practices. This loop involves teachers asking questions to better grasp students' levels of understanding, students responding to the questions orally, in writing, or through diagrams and drawings, and teachers recognizing and acknowledging student responses. However, providing corrections of all erroneous responses is not part of this loop, as the focus is on guiding and supporting student learning rather than simply correcting mistakes. Diagnostic assessments are also an essential part of the assessment process. For example, On the first day of their study of electricity, students might be asked to create a concept map showing what they already know about the topic. This activity helps the teacher identify students' prior knowledge and misconceptions, providing a starting point for instruction. Similarly, asking students to draw and label sketches that illustrate the sequence of an organism's life cycle, such as mealworms, and using a rubric to evaluate these drawings is an example of summative assessment. This type of assessment measures student learning at the end of an instructional period and provides objective criteria for grading. In conclusion, effective assessment practices are crucial for ensuring that students achieve the learning goals set out in the natural science curriculum for grades 1 to 6. By using a variety of assessment methods, including formative and summative assessments, teachers can provide ongoing feedback to students, tailor instruction to meet their needs, and evaluate the overall effectiveness of their science programs. These practices not only support student learning, but also help create a dynamic and responsive learning environment that fosters a deep and lasting understanding of scientific concepts. Unit 8. Using technology tools and resources for science learning. Using technology tools and resources for science learning is an essential component of modern science education. Incorporating technology in the classroom can enhance student engagement, provide access to a wealth of information, and support the development of critical scientific skills. In the context of the natural science curriculum for grades 1 to 6, the integration of technology is not just an addition, but a necessity for fostering a comprehensive and interactive learning environment. General educational technology for K-8 classrooms should minimally include a computer with internet access connected to a classroom projector. This setup enables teachers to display digital content, access online resources, and utilize interactive tools that make science lessons more engaging and effective. For example, a teacher might use a digital projector to show videos of scientific phenomena, conduct virtual lab simulations, or display real-time data from online experiments. Digital technologies for gathering scientific information, data collection, and analysis by students are crucial for supporting engagement in specific science and engineering practices. These technologies include digital microscopes, data loggers, and sensors, which allow students to collect precise data and conduct experiments that would be difficult or impossible to perform manually. For instance, using a digital microscope, students can observe minute details of plant cells or insect parts, enhancing their understanding of biological concepts. Creating and using models of scientific phenomena is another area where technology plays a vital role. Software tools like simulation programs and modeling applications enable students to visualize and manipulate scientific concepts, making abstract ideas more concrete. For example, students can use a simulation program to model the water cycle, observing how water evaporates, condenses, and precipitates. These models help students grasp complex processes and see the cause and effect relationships within scientific phenomena. Communication tools are also integral to the modern science classroom. Platforms for creating and sharing presentations, collaborative documents, and digital portfolios allow students to communicate their findings and ideas effectively. Social media can be a useful resource to support science teaching and learning by providing platforms for students to share their projects, collaborate with peers, and engage with a broader scientific community. For instance, a class might create a blog to document their science projects and experiments, encouraging students to write about their observations and share their learning experiences with others. The use of technology in science education is not limited to the classroom. Online resources and educational websites provide a vast array of materials that can supplement traditional textbooks and classroom instruction. These resources include interactive games, virtual field trips, and instructional videos that cater to different learning styles and keep students engaged. Teachers can assign interactive assignments that require students to use these online tools, thus extending learning beyond the classroom walls. Moreover, technology facilitates differentiated instruction, which is essential for meeting the diverse needs of students. Adaptive learning software can provide personalized learning experiences by adjusting the difficulty level of tasks based on individual student performance. This ensures that all students, regardless of their skill level, can engage with the content at a pace that is appropriate for them. For example, a student struggling with a particular concept might receive additional practice and targeted feedback through an adaptive learning platform, while more advanced students might be challenged with more complex tasks. Assessment is another critical area where technology can enhance science education. Digital tools for formative and summative assessment, such as online quizzes, interactive assessments, and digital rubrics, provide immediate feedback to students and teachers. This real-time feedback helps teachers adjust their instruction to better meet the needs of their students. For instance, a teacher might use an online quiz to quickly assess students' understanding of a recently taught concept and then use the results to guide subsequent lessons. In addition to supporting instruction and assessment, technology fosters collaboration and communication skills, which are vital for scientific inquiry. Collaborative platforms like Google Classroom, Microsoft Teams, and other learning management systems enable students to work together on projects, share resources, and communicate effectively. These tools prepare students for the collaborative nature of scientific work and help them develop essential skills for their future education and careers. The integration of technology in science education also prepares students for a world where technological proficiency is increasingly important. By using digital tools and resources, students become familiar with the technologies that scientists and engineers use in their work, providing them with a glimpse into the real-world applications of their learning. This exposure can inspire students to pursue careers in science, technology, engineering, and mathematics (STEM) fields, contributing to the development of a technologically literate society.